So, okay, in last class, we seen that what do you mean by binary operation? We seen some example. Okay, so what do you mean by binary operation? That is, if S is a non-empty set, then star is a binary operation. There is a rule, that is, if for every element A comma B belongs to S, which implies A star B belongs to S, then star is a binary operation. Okay. Then we seen some examples. We will continue. I think up to this we seen. Is it correct? Okay. See, one thing I can recall. Okay, that is, try to prove not binary. If it is fails, then you can conclude that that is an binary. Okay. How do you prove not binary? There are two cases. In the definition itself, some set is except for some numbers. For example, q is q minus 0, r minus 0, c minus 0. Okay, in that all the set 0 is another member. Okay, suppose what is the is not a member of natural numbers. So natural numbers means positive numbers. Okay, and what is a not a member? 0, negative integers, then rational. Okay, natural except real numbers, then real number except natural numbers, then complex number definitely does not belong to n. So think about, try to prove it is not binary. For that, try to find the example. The result is does not belongs to the corresponding set. Okay, so in the case easily you can identify whether it is not binary or binary. Okay, in natural numbers, clearly when you add two natural numbers again natural numbers, integers clearly again integer, rational number, real, complex, all are definitely well defined. What about q minus 0 and r minus 0? Then that means 0 is not a member. So by using the members of q, try to find 0. Apply the corresponding operation. Okay, how do you get 0? 1 and minus 1 the members of q, then definitely minus 1 plus 1 0, that is does not belongs to q minus 0, so obviously it's not binary. Okay, then now go for the set of all natural numbers. The operation is subtraction. Okay, now anyone tell me minus is binary or not binary? I will explain because it take too much time. So think yourself. Okay, I will give only 10 seconds. Okay, then try to justify whether subtraction operation is binary or not binary in n. 10 seconds are over. So what I told that try to uh, prove not binary. That means when you apply the operation, you will get the negative number because n is a negative integer. Because n is all are positive integer. So which number does not belongs to n? 0 and positive. Okay, obviously choose 1 comma 1, then subtract it. You will get 0, that is does not belongs to n. Therefore, it is not binary. Okay. So similarly for z, it is a binary or not binary. So z means try to prove not binary. In that case, you can get the number which is does not belongs to Z. That means the number may be Q or the number may belongs to R. That is a fractional number or a irrational numbers or complex number. By using the integers, can you get a rational number? That is not possible. Obviously not possible. Choose any integer, subtracted by another integer, definitely you get the integer. Maybe it positive or negative or zero. Okay. So Z contain zero, negative integer, positive integer. Definitely minus is binary in Z. Okay. Jayashree gave the correct answer. Barney Sri and Nandini Sinja. Okay, good. What about subtraction in Q? So obviously that is also satisfied. Okay, because rational numbers, subtraction of two rational numbers, again a rational number, because subtraction of two rational cannot be irrational, cannot be complex. Then real numbers, that is also binary. Okay, now what about the complex number? Definitely that is also binary. Now tell me, subtraction is binary or not binary in Q minus 0? Anyone answer me? Yes, I asked one by one. Faizan Ali, try to answer me. Subtraction is binary or not binary in Q minus 0? So try to prove not binary. For that, you have to think about the number does not belongs to Q minus 0. So first find that number. Which number does not belongs to Q minus 0? 0. By using subtraction, try to get 0. Choose two numbers from Q minus 0, then subtract it. There is a possible for getting 0. You have to think like that. Definitely you will get the answer. Faizan Ali didn't reply me. Then Gayatri, Giridharan, yes. Guru Darshan, someone reply me. Gayatri, not binary. Good. I will note your name. Gayatri. Okay, good. Then give the example. Simply 1 minus 1. Okay, 1 minus 1 becomes 0. 0 does not belongs to Q minus 0. So definitely it is not binary. Okay, good. And what about multiplication in n? If you multiply any two number, any two positive integer, it possible for getting negative or 0? Not possible. So definitely star is binary in n. What about multiplication? Star means multiplication. What about multiplication in Z? What about multiplication in Z? Binary. Good. If you multiply, see, which number does not belong to Z? Rational, irrational, complex number. If you multiply two integer, it is possible that getting a rational or irrational or complex, not possible, because when you multiply two integer, you will get again a integer. So that is also binary. So similarly Q. In Q, multiplication is binary. R is a multiplication binary. Q is a multiplication binary. What about Q minus 0? So multiplication. Someone says binary. Okay. What about Guru Darshan? Hariharan P. Hariharan R. Hariharan S. No one reply me. Harini M. Harish R. Someone reply me. Harini M. Binary. Okay, good. I will note the Harini name also. Harini. So, because we think about not binary. So, for proving not binary, I have to get 0. Because 0 doesn't belongs to Q minus 0. So when you multiply two two non-zero number, there's a possible of getting zero? No. Because if you multiply two number, the result is zero means any one of the number definitely zero. Okay. So definitely it's a binary. The next four lines very important. Okay. What about division is whether binary in set of all natural numbers? Harshita, Harshita Kendarwal, Hiba Ashina, Hemalata. See, try to think that choose two positive integers, then divide them. It may be negative integer, or it may be rational, or it may be irrational. There is a possible of getting negative integer or rational or irrational. If it is possible, then not binary. I am asking Hashita Kendalwal, Hiba Hashina, Hemlada. No one reply me. Hemlada, not binary. Okay, I will note your name. Good. Because if you choose any two number, okay, in set of all natural numbers, say 2 and 3, divide it 2 by 3, definitely it does not belong to n. Okay, so division is not binary in n. Okay, next one is a clever thing. Can you say that division is binary in Z? Hasita also replied me. Hashita, Hashita J. Hrithik Govul, Jayasri or Jayasri B. Jayasri or no. Good. Why? The same thing. Because Z is set of all positive integer, negative integer, 0. If you choose two numbers, there is 2 and 3, divide them, 2 by 3 does not belong to Z. So it's not binary. Good. The next one is critical one. You have to cleverly think that then only you can answer it. See, out of 5, 15, so 5, 10, 15, 16, 17. So this is the 8th one. So this is the most critical one. Try to find the answer. Whether division is binary in Q or not. I didn't give the clue. Just try to find the answer. Later I will give the clue. The remaining Jayasuriya, Jagannathan, KR, Josephine Salome, Joe Samuel, Joshua, Joel Victor Franklin, Harty ANM, okay. Sincerely sorry, because I think that definitely you can give the answer binary. Many of them give the answer binary. If you search in the chat box, many member give the answer binary. I think that many people give the answer binary, but the answer is not binary. Now try to find the example. I think two of them, three of them give the correct answer. Josephine Salome, I will note the name. Jos. Okay, Vignesh, Vinusa, Josephine gave the correct answer. Good. So the remaining already gave the wrong answer. Try to think about the example. Already every time I told that try to prove not binary. That means try to find the number which is does not belong to Q. Sanjay, you gave the example for there is a division is applicable in Q. So if you choose any two number, just divide, you will get the again a rational number. Okay, at least anyone, Vignesh, Vinusha, Josephine, anyone give the example? Okay, first of all, tell me which number does not belongs to Q. If you find that number, easily you can find the answer. You may think that irrational not possible. When you divide two number, there is a possible of irrational. Okay, that is also possible. Okay, try it. Super. I think Minusha and Ujwala gave the correct answer. That is, the initial itself already introduced the set does not contain the member. I list out the member which is does not contain in the set. In natural number, negative integers does not belongs to n, rational, irrational, complex. In Z, uh, the irrational does not belongs to Z, rational does not belongs to Z, complex. In Q, especially I mention one number, it's not a number, that is infinite. Infinite is not a number, it's a symbol. It does not belongs to any number system. Okay, try to get the number infinity. Choose two number from Q, divide it, and try to get the number infinity. Is it possible? Sanjay. Definitely any positive integer or any negative integer, it is any non-zero number by zero, definitely it's an infinite, so that is not defined. So division is not binary in Q. Division is not binary in Q. Think about the number which is does not belongs to the corresponding set. Then only you can able to prove the corresponding operation is not binary. Okay. You may think that irrational does not belongs to Q, then complex number does not belongs to Q. But you have to think that infinity also does not belongs to any number system. Okay? Sanjay, is it correct? You gave the answer no. For which you gave the answer no.
Sir, I thought you went to Q minus 0, sir.
Okay, thank you. So next one, similarly R. Definitely R also not binary because infinity does not belongs to R. Any real number by 0, definitely it's infinity. Similarly C, that is also set of a complex number, and the division not binary because any complex number by 0, that is infinite. Then now tell me for the last case, division is possible in Q minus 0. If you choose two rational number, just divide it. The resultant is a rational number. Anyone reply me, please? It's a binary. Anyone? Any answer binary? Kausika or Nandini Sindhuja and Sanjay Sharan gave the answer binary. Anyone have the answer other than binary? Sir, your voice is echoing. మా వాయిస్ ఇప్ప కరెక్ట్గా ఎక్కువ అదా கரெக்டா இல்ல இல்ல எனக்கு எக்கோ ஆயிட்டே இருக்கு சார் ஓகே எஸ் சார் இந்த மைக் ஆஃப் பண்ணல ஓகே 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 now I think my voice is okay okay so only the first starting itself I am asking my voice is echo or not. Okay, now I think my voice is clear. Now tell me, is a binary or not? Okay, is binary. See, if you have any disturbance in my voice, please inform me, sir. Voice is not audible. Okay, voice are breaking. There is a extra sound. There is no voice. Please inform me because I am dealing with the laptop as well as my mobile. So I don't know about whether my voice is clear or echo or disturbance. I don't know anything. So if you reply me, then only I can correct my voice. Okay. So if you choose any two, if you choose any two rational number, then divide it. Definitely, it's again a rational number. My voice is clear now. My voice is clear.
Yes, sir.
Okay, thank you. So these are all basic things for we verifying operation in basic our number system. We know we have a number system. In the number system, just I try to find whether my basic operation is binary or not. Like that, you have to verify the remaining three axioms. Then finally, you can conclude that that is a group or not. Okay. So a few more example I want to explain to you. Okay. These are a few examples. So negative is not binary in n because if we choose 2 and 3 in n, 2 minus 3 which is minus 1 does not belong to n. Similarly, the another example for division is not binary in n, then division is not binary in z, I gave the example. Then division is not binary in q, that is also already gave the example. Then division is not binary in r, that is also I gave the example. Then division is not binary in C also. Then plus or minus 1 is not binary in Q minus 0, already we discussed. Similarly, plus or minus 1 is not binary in R minus 0, that is also we discussed. Plus minus 1 and minus 1 is not binary in C minus 0, that is also we discussed. More examples. Now tell me, this is an interesting problem. So now we move on to the other operation which we familiar with: addition, subtraction, multiplication, division. These four operations are familiar. Okay. So out of the operation addition, subtraction, multiplication, division, we have some more operations are there. By using that operation, we have to verify whether it is binary or not. So these examples are purely chosen from the plus two books only. Okay. Already you studied plus two. Try to take the plus two max book. These examples are belongs to plus two book only. So lot of informations are there in your plus two book itself. So because already you studied group theory in plus two, here we are going to study ring theory and field theory as well as some more group structures. Okay. Now tell me, my set is set of all natural numbers. My operation is nothing but if you choose two number in n, set of all natural numbers, if you apply the corresponding operation, that means the first number A, second number B. If you apply the operation, first number make it as a base, the second number make it as a power, so resultant is A power B. If we choose any two number in n, the resultant is a power b, the first number power second number. Whether this operation is binary or not. My set is set of all natural number. My operation is nothing but first number is base, second number is power. So whether this operation is binary or not, please reply me. I end with Kartiyaniam, Kartik Raja, Kirti Vashan, sorry, Karthi Srinivasan, no one reply me. Kausika, Kirtana A, Kirtana B, Kirtana NV, Kritiya V, Kishore P. No one need the extra mark. Is it correct? Huh? No one replying me. So no one need the extra mark. Okay. Kishore Kumar A, Kishore Dheeraj, Uduvayur, I think Aravind, Kishore Kumar. Yes, sir. I note the name Kishore Kumar. So end of the section, I will end of the session, I will read out the name who are going to get the extra mark. Okay. So any one of the name missed out. So after the complete the class, call me and inform your name. So Kishore Kumar gave the answer. It is yes, sir. Obviously, yes, because n means set of all natural numbers. The base is positive integer. The power also positive integer. So the resultant also a positive integer. Exactly correct. This is a binary operation. Good, Kisukuma. So next one is, suppose if you choose the set Z, this is not a binary. See the example. If you choose a positive number and negative number, then positive number is base, negative number has a power, then the resultant is 3 power minus 1, which is 1 by 3, which is does not belong to Z. In that case, my binary, my star is binary operation is not binary on Z. Did you understand? So if you change the set, definitely sometime the binary is not works, sometime the binary will works. Okay, clear? If it is the set n, a star b is equal to a per b, definitely is definitely it's a binary. If I change the set z, it's a not binary. Okay. Another thing. So my set is set of all real numbers. My set is set of all real numbers. My binary is star. The first case, a star b is maximum of a comma b. So I have a set of all real number. My operation is, if you choose two number, the operation uh, did choose the minimum number. That is the work of the corresponding operation star. The star will do choose the minimum value of a and b, whether it is this operation is binary or not. Similarly, the second operation, maximum of a comma b, which is a binary or not. Then third operation, when you if you choose two number a and b, apply the operation, the output is only the first number, whether it is a binary or not. One more example, if you choose two number from the real number, then operate it, the output is only the second number, whether it is binary or not. I will give the 13 seconds. Try to find whether first one is binary or not, second one is binary or not, third one is binary or not, fourth one is binary or not. I will give the time 30 seconds. Try to find it. Okay, time is over. Now tell me, I think Aravind, Kausik Iswar, Kristen Paul, Kishan, Krishan, Lagan Kapoor, Lakshana, Logeshwari, Magek Divya. Maybe my pronunciation is wrong. Okay, Magendran, Manoj, Meena Chikayar, Wasim, Monica. No one give the answer. Moon is D. At least try to tell 1 and 2. More is Darren. The Nandiswaran, Nandini Sindhuja, Narayani Satyan, Nandini. Which one is binary? First one or second one? Monica. Nandini and Monica. And I will note the name. Nandini. First one is binary. Okay, I will note it down. Monica AR. Okay, Nandini, which one? First one or second one or third one or fourth one? Narayani, Naren, Nitish Kumar, Nitya Lakshmi, Penny, Unmoli, Sir, I think all are the binary. You think all are the binary. Nandini. Okay. Naren, binary. I will note the name Naren also. Punmoli, Pradixina, Prasanna Venkatesh, Preeti Chakravarti, Pravi, Pravina, Pravina Menana, Preeti, Vishnu Priya, Sanjay Sarana. Now, voice is audible. Swati and
Yeah.
Udyu. Okay, thank you, thank you. So, in the slide itself, already gave the answer. Clearly, all the above operations are binary. But even though many people didn't reply me, so I called those some names. So, many members they didn't reply. Okay, no problem. Okay, all the four binary operations are, sir, all four operations are binary. Good. Then we deal with some more examples. Suppose my set is set of all natural numbers. My star is defined by a star b is equal to ab plus 5. You have to clearly understand the operation, binary operation. After that, you have to check whether it's binary or not. A star b means before the star I have the number a, after the star I have the number b. The operation is nothing but just multiply before and after plus 5. This is operation did. The operation for a and b is nothing but before star I have a, after star I have b. The operation nothing but before plus after plus 5. This is the operation. Okay. Now, whether it is binary or not, it's obviously binary because if you choose two number from n, definitely you can know that multiplication is binary in n. So definitely AB is a binary. AB is belongs to n. But 5, we have a number, new number 5. So obviously 5 is belongs to n. So AB belongs to n, 5 belongs to n. Then addition of AB plus 5 also belongs to n because addition is binary in n. So finally we conclude that star is an binary in n. Because product of two natural numbers is a natural number, addition of two natural numbers is a natural number. This is nothing but addition is binary on n. Multiplication also binary on n. The next example. When you change the set, already I told that if you change the set, sometime binary become a not binary, sometime not binary become a binary. Here in earlier case, I choose wait. Earlier case I choose my set is n, but here my set is n, but a small change. My binary operation is nothing. Binary operation is defined by A star B. A is a number which is before star. B is a number which is after star. So binary operation defined by before star and after star. Just multiplication of before star and after star, then subtracted by 5. Okay. So easily I can know that A and B belongs to n. Definitely AB belongs to n. 5 also belongs to n. But AB minus 5 does not belong to n because we know that suppose AB is greater than 5, definitely it belongs to n. AB is lesser than 5 definitely does not belong to N because subtraction is not binary in N. So finally we conclude that star is a not binary in N. Then similarly few examples. Let S equal to set of all real numbers. My operation is A star B means see. So suppose I telling the way of the operations defined between A and B. If you understand the operation very clear, then only you can apply the problem. Okay, that is A star B means before star A, after star B. So before plus after plus product of before and after. So this way you have to understand the definition of binary operation. Okay. So the binary operation defined by A star B as A plus B into AB, whether it is binary or not, clearly binary because A and B belongs to R, A plus B, there is a addition is binary in R, product also is binary in R, finally A plus B plus AB is binary in R. Okay, another interesting example, S means set of all odd integers, my binary operation is addition, whether it is binary or not, it's not a binary because when you add the odd integer, the result will become an even integer. Okay. So, uh, so S means set of all odd integers. So one is an odd number, 3 is an odd number. If you add it 1 plus 3, 4, that is also an odd integer. I think here I choose 3 and minus 3. 3 is an odd integer, minus 3 also odd integer. If you add it, here I miss minus sign. Okay, 3 is an odd integer, minus 3 is also odd integer. If you add it, 3 minus 3 becomes 0, that is does not belongs to set of all odd integer because odd integer means plus or minus 1, plus or minus 3, plus or minus. In another example, choose 1 comma 3 belongs to O, that is nothing but set of all odd integer. When you add it, 1 plus 3 becomes 4, that is an even integer which is does not belongs to the set of all odd integers. Then if you choose the multiplication, that is a binary because product of two odd integers is again odd integers. So definitely in the set of odd integers, multiplication is binary. If I choose set of all m by n matters or n by n matters, if you choose any one, and addition subtraction always is binary. Addition of two matrices, addition subtraction of two matrices are m by n or n by n. N by n is the most general case. Okay, so under addition subtraction is a binary. These all examples I taken from only your plus 2 books. If I choose n by n matrix, under specification my A is singular matrix. What do you mean by singular? Determinant of matrix 0, then it's a singular matrix. Oh, under addition, it's a not binary because addition of two singular matrices need not be a singular matrix. Okay. If you choose 1, if you choose 1 0 0 0, okay, 1 2 by 2 matrix, the another 2 by 2 matrix 0 0 0 1. If you add it 1 0 0 1, the resultant is non-singular because the determinant is 1. So obviously addition of two singular matrix need not be a singular matrix. It's not binary. Similarly, under matrix multiplication is a binary operation on the set of all singular matrices as well as non-singular matrices. Similarly, cross product is a binary operation on the set of all vectors, but dot product is not a binary operation on the vectors. You know, if you take two vector, apply the dot product, the result is a scalar. So definitely it's not binary. If you take a two vector, apply the cross product, it's again a vector. So cross product on the set of all vectors is a binary, but dot product on the set of all vectors is not a binary. Suppose A is a set of all m by n real matrix, then S is not closed with respect to an unary operation of the transposition. So this is another example for matrix with not binary. Okay, I choose a m by n real matrix. If you apply the unary operation transpose, definitely does not belong to S because S is a m by n matrix. If you transpose the given matrix, it's a n by n matrix which does not belong to S. So transpose is not closed in the m by n matrix system. Okay. Many examples are there. All are very well about Boolean algebra. The set 0, 1 and addition is a binary. Clearly is a binary. And the multiplication also binary, because multiplication of two binary already you know very well. So that is an binary. Now, before I am going to define a definition, I discuss few things. Just try to pin my another name. Okay. My voice is audible. My phone is visible. That I show some seats. Okay. Okay. So up to this we define. We have a set. In that set, we have some number. Whether that number that we have some operation, whether that operation is valid in that set or not. Up to this we stated this thing only. We have a set, we have some operation, whether the operation is valid in the set. This is called the operation is binary on the set. This is nothing but our first axiom of our group, that is closure axiom. We have a set, we define some operation, choose any two elements from the set, apply the operation, the resultant also belongs to the set, then we say that the closure axiom is satisfied. Okay. Okay. Suppose I choose okay. Okay. Suppose I'm going to write. So suppose I take there is a column. Suppose I choose the set of all natural numbers, say 1, 2, 3, etc. Okay. So define my operation is, my operation binary operation is star. My binary operation is star. Okay. So my first check is whether this operation is valid in the set or not. Okay. Second thing, suppose I choose two numbers, say 2 plus 3. Okay. The operation is valid. Suppose if you add one more number, okay, that is 2 plus 3 plus 4, whether this expression is equal to, if we change the bracket, 2 plus 3 plus 4, whether two expressions are same or not. We try to check. We try to check. Okay. 2 plus 3 plus 4, which is equal to 2 plus 3 plus 4. 2 plus 3 plus 4. Whether this structure is same or not. Okay. We have to check this structure. First thing, my check is whether my operation is valid or not. This is nothing but my closure axiom. The next check is whether this structure is satisfied or not. This is nothing but my associative axiom. If you change the bracket, the resultant is same or not. This is represented by the associative axiom. For this, we need three numbers. So now I am going to define the associative axiom. That is, for any three element ABC, ABC. Okay, wait. A comma B comma C, which is belongs to N. Okay, which is belongs to N, which implies I have to check A plus B plus C, which is equal to A plus B plus C. So that is, if you choose three numbers from the given set, just first I added A plus C, then add with A, or first I add with A plus B, then add with C. Both expressions are same. Then we can say that my operation addition is associative. Associative. So first is my operation, binary operation is nothing but closure or not. That is nothing but closure axiom. Next one is my operation is associative or not. Okay. Then this is second condition. First is closure axiom. Second one is associative axiom. The third one is, see, I choose a set of all integers. I choose set of all integers. Up to this, I stop the class. Okay. Okay. My idea is, if I choose any element, in Z, if I choose any element in Z, I add with some number. If I choose any element in Z, I choose, I add with some element, but my idea is I will get the same element. What is my idea? Choose any element in Z, then add with the fixed element. This resultant is the same element. This property is nothing but identity axiom. This property is nothing but identity axiom. My idea is, if I choose any element in Z, then add with the fixed element, the resultant is the same element. This structure, this type of axiom is nothing but my identity axiom. Okay. So now I define the identity axiom. That is, any element in the given set, okay, there exists a fixed element in that set such that apply the operation, say A plus E or E plus A, the resultant is A, such type of number, if it is exist, such type of number is exist, then we say that my addition is, that is, this is called identity axiom. This is called identity axiom. So set with operation satisfy the four condition. It's called group. So first, set with addition, check the binary operation. That is nothing but closed axiom. Set with the operation addition, we can check the associative axiom. Then set with the addition, I am going to check the identity axiom. If it is satisfied, this is called identity axiom. That E should be exist. This is clear. Is it correct? A plus B equal to E plus A equal to, but E should belong to the set. This is most important key point. This is more important key point. If it is satisfied, definitely this is nothing but our identity axiom. So the time is over. The next class detail I will explain why we need this identity axiom, why we need this associative axiom, why we need this closed axiom, why we need in the inverse axiom. I will explain in the next class. So why we have to consider like this? So we have a set, we have some operation. Why I have to check these four axiom? Then why we clubbing these four axiom as a group? There is any rule behind this? Definitely yes. Definitely yes. So there is a reason. Then only they say that the collection of these four axioms form a groups. Okay, we'll explain why we concentrate on these four axiom: closer, associative, identity, and inverse. I will explain in the next class. Okay, thank you, students.